Okay, Excel, paper 1 2018, question 4. In fact, we don't need the calculator for this one. All right, let's go. So, question 1 is a multiple choice question. So 4A is a 1-mark multiple choice question, and it's basically asking us about vectors and scalars for force and velocity. So what would be correct about force and velocity in terms of whether they are vectors or scalars? Vectors have a magnitude and a direction. Forces, direction always matters. Okay, so whenever you've got a force, it's always going to be a vector because you know we draw force arrows on to show which way the force is acting. And velocity is a speed in a particular direction, so that is also a vector. So we're going to choose option D for that one. Okay. Next up, we have an object orbiting around Pedro in this case. So what would keep an object orbiting around a planet-sized being like this? That force would be gravitational. Would be a gravitational force. But also we've got force in a circular motion. So force acting in a circular motion is also centripetal. So either of those answers is good. We've got gravitational force because we've got a massive body here attracting the satellite, but we've also got the idea of something moving in a circular motion. So that's 1 mark there. And then the last mark on this page, another mark, that was B part 1, B part 2. Got another mark for drawing an arrow, and the arrow is going to act towards the center of gravity of the object. So the force is acting towards the center of gravity of the object. The object isn't going to move in that direction because it's already going in this direction. So what ends up is it ends up moving. If I do a top-down view, if the force is in this direction and the motion is in this direction, the consequence is it starts to go in a curve. And then at this point here, the force is in this direction and the motion is in this direction, and so on. So if something's in circular orbit, then the direction of motion and the force acting are at right angles, and that just keeps it going round and round in a circle. Okay, let's flip over to the next page. And we've got some stuff about astronomy. So our satellites are used to gather data. For C here, satellites are used to gather data about the universe. And we've got this theory of the Big Bang Theory, origin of the universe, and evidence is redshift and CMB. So we've got evidence of redshift, or these two things provide us evidence for the Big Bang. We're going to have a few questions about why that is. So first question, 2 marks. Simply what is meant by redshift? What is meant by redshift? And essentially, if an object moves away from us, then the waves spread out. So let's take an object that's going to move very fast away from us, potentially a galaxy or a star. Let's take a star as an example. So as a star moves away from Earth, the wavelength of light increases. It's spreading out, and that would get us our 2 marks. We could say, instead of the wavelength increases, we could also say the frequency decreases. Okay, both of those, either that or that, is going to get the 2nd mark. As an object moves away from us, the wavelength of light increases or the frequency decreases. Okay, that was C part 1, C part 2. Another 2 mark question. Explain how redshift provides evidence for the Big Bang Theory. Well, the Big Bang Theory proposes that the universe is expanding. So if we have evidence that everything is moving away from us, or all the galaxies are moving away from us, then, you know, if we imagine, let's say Earth's here, and let's take some galaxies that are here, here, and here, and they're moving away from us. Well, in the future, they'll be further from us. So what happens if we go back in time, or we go back in time and the galaxies were closer to us, we go back far enough, everything was in the same place. So Big Bang, just bring this down here again so we can see the Big Bang predicts an expanding universe. Redshift shows the galaxies moving away from us. That's going to get our 2 marks. But also worth noting, or another point could be for a different mark, that the further away they are, the faster their speed is. Again, think about this. If we all start in one place, the stuff that's further away must be moving faster. So galaxies that are further away are moving faster. I'm going to keep it simple, moving at greater speed. So just to be clear, you've got your 2 marks here, but that's another thing that you could add, galaxies that are further away and moving at greater speed. All right, part 3. There is a satellite, COBE, that explores radiation, or did explore radiation in the past, looking at CMB radiation. And the question is simple, 1 mark question is, what does the M stand for? So do you know what the M stands for? So this is the Cosmic Background Explorer that's looked at this radiation. So it's looking at the cosmic microwave background radiation. And what do we mean by that? So what is meant by CMB radiation? It is radiation that's everywhere in the sky. So we believe it's left over from the Big Bang. So radiation that comes from everywhere in space. We could say in the sky or in the universe, radiation that comes from everywhere in space. And then last question, last part, can I fit it onto this page? Yes, I think I can. Last part for question 4 is explain how the presence of CMB radiation provides evidence for the Big Bang. Okay, so why does that provide evidence for the Big Bang? The Big Bang theory proposes that the universe had a beginning Let's try and spell properly. Sorry, must that out. Has a beginning that released energy that is still detected now. So how does it provide evidence for the Big Bang Theory? Well, the Big Bang Theory proposes there was a start. So the fact there's radiation everywhere in space suggests that the universe had a beginning, had a start, and that was the CMB. Okay, that is question 4.